We're recording. We're recording. We're live, baby. This is 10-2. Vectors in space. Ooh. Vectors. So, all this is applying what you learned about vectors back in chapter, I don't remember what chapter it is, to 3 dimensions. So if you have a vector, it can be broken up into its components, and those components can be listed as v1, comma, v2, and comma, and v3. So this is like the x component, right? This is like the y component, and this is like the z component. Another way you can write the same thing is v1, go ahead, sharpen away. v1 in the I direction plus v1 in the I direction plus v2 in the j direction plus v3 in the k direction. But I'm not very good at drawing cursive k's, even though it's supposed to be cursive, so I'm going to just draw it like that. Okay? The standard unit vectors, standard unit vectors are as follows. I is the vector 1, 0, 0. J is the vector 0, 1, 0. And K, let me see if I could do a cursive case. I failed cursive in 3rd grade. That's not a cursive. Is that a cursive? That did it, okay. And K is equal to 0, 0, 1. Okay? So these are just unit vectors. In other words, if I were to draw my xy plane, xyz plane, the unit vectors are vectors with a length of 1. So this one, so here's your I unit vector, your j unit vector, and your z unit vector. So this would be like not z, and k up here. So those are just vectors with a length of 1. That's what the standard unit vectors are. Okay? The zero vector looks like, guess what that looks like? What do you think I have in all the spots? Zeros, right? 0, 0, 0 is a zero vector. Okay? And then component form of a vector. Yes, sir?
I'm going to varsity soccer game. I'm manager for it.
You're the manager for the soccer team.
Yeah, both soccer teams.
Boys and girls?
No, JV and varsity girls.
Okay. Wait, you're interrupting my cutting edge video. Component form of vector, new page. Component form, I don't like red. Component form, and it's just kind of a lot of tedious stuff here, but we'll get through it. So if you have one point, so if you have a point in the 3-dimensional plane P, which has coordinates P1, comma, P, those are little p's, P3, and you have another point Q, which goes from Q1, those should be lowercase q's, shouldn't they? Point Q, Michael, I'm talking the whole time, I'm talking, okay? Please, Q1, Q2, and Q3. Then you can find the vector from P to Q, okay? So PQ might represent a vector, kind of like that, right? Is that how you draw vectors? In science, right? In physics? You with a little hat on top of it like that? So the vector from P to Q looks like, you just, looks like Q1, Q, you just subtract it's like y2 or z2 or x2 minus x1, y2 minus y1. So you go Q1 minus P1 comma, Q2 minus P2, comma, Q3 minus P3. And that would be your vector from P to Q. So you take the coordinates of the Q minus the coordinates of the P and you can find. Okay? The magnitude of a vector, magnitude, okay? How do you spell that? That's wrong. I know, what happened? So the magnitude of a vector is given by this symbol, V, with double bars on the end. And do you guys remember, you just take the square root of V1 squared plus V2 squared plus V3 squared. Okay, so you just take each of its components, you square it, and take the square root of it. A unit vector, you guys remember what a unit vector is? I find a unit vector. Anyone remember? Go ahead, Mitch.
I actually have a question.
Yes.
So Q1 minus P1 would equal V1.
Q1 minus P1 would be equivalent to V1.
Okay, thanks.
And Q2 minus P2 would be V2. And Q3 minus P3 would be V3. Very good. Okay? So, yes, that's correct. Okay? The unit vector, you guys don't remember? You just divide it by the magnitude. So you would take the vector and you would divide it by its magnitude. So, for example, let's kind of put this all together. Okay, find the component form of the vector from, I have some numbers, from P, which is 2, -4, 1, to Q, which is 570, and then find its unit vector. Find its unit vector. Can you read that? Okay? Yes? You can see that? So if I were doing this problem, I would just, so let's call this vector B. Who can tell me what vector B is? Tell me vector B. You do it. Michael's going to tell me. You're looking. Michael, tell me what vector B is. Subtract Q minus P. 3, yes. 11, yes. You the man, okay? There you go. Very good, okay? So this is find the component form, and so that's the component form of the vector, so it's 3, 11, -1. And then the unit vector, what's the unit vector? Who's got the unit vector? Go ahead, Jack.
So 3 over the square root
Yep.
of 131.
Very good. 3 over the square root of 131. And if you don't know how we got that, he took 3 squared, 11 squared, and 1 squared, add them all together, took the square root, keep going.
11 over the square root.
11 over the square root of 131 and -1 square root of 131. Uh-oh. The Moby's running. And you would put these kind of brackets around that too. Yeah. Oh, can I do that? Oh, I can. Okay. If I were going to sketch this in, so let's just sketch it because it's fun. Right? Isn't it fun to sketch it? Maybe. There. So if I were going to draw an X, here's X. I mean, that's Z. Here's X. Here's Y. And up and down is Z. So I'm going to go out 3. I don't know if this is really the out 3. Oh, way over 11 and down 1. So maybe this vector looks something, I'm not sure what that vector looks like, but maybe this is the vector right here. Okay? the unit vector, so if this is v over here, that's kind of hard to represent, but it's going over 1, out this way 11, down 1 unit. And the unit vector is just a vector in exactly the same direction, right? Except it's got its length would be equal to 1. So this would be like the u vector right there. You get that? We did this in 2 dimensions, so it's kind of the same thing in 3 dimensions. So this is your x, your y, your z. All right. Done with that? Questions? We found its magnitude. We found it. What else do I have to talk about? You can multiply vectors by a constant. I'm not going to talk about that right now. We'll talk about dot products. You guys remember dot products?
Yes.
They're easy. Dot products. So the dot product by itself doesn't really have a whole lot of meaning, but you use it in work, and you also use it to find the angle between 2 vectors. So say, so the dot product of u dot v is equal to u times, it's u1 times v1 plus u2 times v2 plus u3 times v3. And then, so say I have 2 vectors. U equals 2, 6, 2. 2, 6, 2. And B equals -1, 5, 0. Okay. Dot product U dot B. Who's got this? I'm gonna pick on you. Who's got U dot B? Who's got U dot B? Dan's got it. Go ahead, Dan. You have to earn that Tootsie Pop.
-2,
-2, that's right.
30,
Plus 30
and then 0.
plus 0 makes
20.
28. That's all there is to it, right? It's just a number. The dot product is just a number. Okay? Furthermore, the cosine of theta, so this is the same as it was for 2 dimensions. The cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. So say in this case, I say find, this is for finding the angle between u and v. Okay? So we're gonna look at these u and v. We already know u dot v. Okay? So cosine theta is equal to 28 over the magnitude. What's the magnitude of u? Here's u. Who can give me the magnitude of u? Can I just stickly Maria? What's huge? It's yeah, square root of 44. That's correct? Okay. Square root of 44. Everyone sees where Anna Marie Castigli got that from? I would just like saying your name. Okay. This squared plus this squared plus this squared, and this is the square root of 26. Okay. So then you take your calculadora and you take the inverse cosine of, you have to make sure you're in degree mode of that, okay? You don't have to multiply the 40, whoops. You want to take the inverse cosine of the square root of 28 over the square root of 44 times the square root of 26. And did I do that already? I did not do that already. So let's do it. Where's my calculator? What do you get?
1 squared plus 1 squared.
Let's do it. I did it in different numbers in different class. So I'm going to go second cosine of 28 divided by, and you have to use parentheses on the bottom, otherwise it will divide by one thing and then multiply second square root of 44 close that parentheses, another parentheses. Am I doing this? Is this, uh-oh. No, that's right. Second, I'm good. Square root of 26, close that parentheses, close that parentheses, be done. Oh, close this parentheses, right? I need 3 sec because I'm taking the code. Let's see if that works. And I get 34.12 degrees. So that is approximately 34.1 degrees. Let's draw a picture of it just to see if it kind of makes sense, okay? So it helps to kind of visualize these things, and it's hard to visualize things in 3 dimensions. But if 262, let's see, let's change colors. So 262, where's that? Out 2 over 6 up 2. So let's say that 262 out 2 over 6 up 2. So let's say that this is 262. And then this one, -1 means I go backwards 1, out 5, and up 0. So that it'll look something like that. Does it appear that the angle between those two vectors could be 34.1 degrees? About? That looks like it might be, right? Yeah, I mean, this one isn't going like way over here. So it's kind of hard to tell in 3 dimensions, but sure. So here's your theta is right in here. So, I mean, they're kind of in different planes. Well, they're in the same plane, but they're kind of going, one's going up and one's going out. But so that's that angle, right? Questions about that? Easy enough so far. What else do we got for you? I think you could do that. Also orthogonal. Orthogonal. What does orthogonal mean? Do you guys remember? Yeah, orthogonal means really that they're at right angles to each other. Perpendicular. Whoops, that's not a very good if, is it? If u dot v is equal to
1.
not 1, 0, right? Because remember that the cosine of 90 degrees is 0. So if u dot v is equal to 0, that'd say that the cosine of theta is equal to 0. That would mean that that angle would have to be 90 degrees. Right? Yes? Hello? You good? Yes? Understand? Okay. So how do you tell if they're parallel? Okay? So u and v are parallel if u is equal to c times v, where c is a constant, okay? So for example, if I have some vector like 3, -1, and 4, okay? Here's some vector, and we'll call this u. And I have another vector, we're going to call this one -9, +3, +3, -12. Parallel, perpendicular, neither. Parallel, perp, or neither. What do you think?
Oh, they're parallel.
How do you know? Mitch?
Parallel because they've all been multiplied by negative.
Right, because if I take u and multiply it by -3, I get this one, right? So in this case, v is equal to 3 times u, right? And so therefore, this means therefore. Therefore, they're parallel. And you can't be parallel and perpendicular at the same time, right? Right? Can you? Can you be parallel and perpendicular? I'm almost done. I only have one more problem. I promise. Okay. So, and then you won't have to listen to me. So this is the one I messed up on the last class, but I got it figured out now. So don't worry. Okay. So vector v, there's one like this on your homework, and it's lies in the there's a little more to it than this, but I think you guys could figure out most of this stuff as you work through it, okay? In the XZ plane, and has a magnitude of 10, okay? And makes a 60-degree angle with the positive z-axis. Find the component form of B. So sometimes it's useful to draw a picture. So in other words, you have this, you have this, you have this, okay? So if I were to go back this way, I'm going to do this. I'm going to go back this way. I'm going to go back this way. And go down this way, okay? So there's some vector, solid line, which is called V, and it's in this plane right here. This is, hey, this is X, this is Y, positive Y-axis, right? This is the Z-axis. But this vector is in this plane. So this vector is kind of going to come, it's going to be going up, whoops, where's my tool? Going to be going up this way. And can you visualize that? Maybe, yes? Not really. So it's within this. So if I were to draw, let's see if I can do this, okay? So if I were to draw this going up kind of like this vector is contained in this plane going across, right? Okay? But you don't really have to do that, because if it's in this plane and I drew it in 2 dimensions, okay? Here's this dimension, here's this dimension, okay? Here's I should draw those black, but that's okay. Here's my vector going up this way, okay? So here's vector V. I could break it into this component and to this component going this way, and this component going this way. This is the what component? I, J, or K?
K.
This is going up, so that's K. This is going along this axis, so what's this component coming down this way? That is the I, okay? What's the J component if it lies in this plane? There is none, okay? So this vector is going to look like something, comma, 0, comma, something. Do you guys understand that? Okay? Because it's contained in this plane, so there is no Y or J component to it, right? So it's not going this way at all. It's just, so if I looked on it, if I were standing over here somewhere, I would see this picture, right? So then, if I know that this angle is 60 degrees right here, and I know that this is 10, how can I find I and K? How can I find I and K? Or we could call it B1 and B2. Yeah, right. So I is opposite, that's hypotenuse. So sine of 60, we'll just call it, in this case, is equal to I over 10. And the cosine of 60 is equal to what? Adjacent over hypotenuse, K over 10, right? And so, do you remember what sine of 60, who remembers what sine of 60 is?
1/2.
Root of 3 over 2, okay? almost. Mrs. Hines is going to get mad at me next year. So I is equal to 10 times the square root of 3 over 2. And j is equal to 10 times cosine of 60. 1/2. Okay? So that's equal to 5. And that's equal to 5 root 3. So my component form of this vector looks like 5 root 3, 0, and 5. You guys understand what I just did? Because there's no j component, so you can just look at it in 2 dimensions and see this going like this. So this is going up like this, and this is going out like this. And even though it doesn't look like it from this perspective, your right angle, this is where I messed up with the other class, this is my right angle right there. See that? Okay? So you can see it in 3D, right? Going up this way and over this way and out and up. All right? Hey, isn't that a good picture? Come on, give me props. Props? Is that what you said? Okay. Guess what? The end.
Coolest kid on the block.
That says B. Yeah. All right. I'm done. You can. Whoa.